So now we'll start using permutations and combinations with probability. So let's take a look at this. It says a student advisory board has 17 members. 3 members serve as chair, secretary, and webmaster. Okay. Each member is equally likely to serve in any of the positions. What's the probability of randomly picking the 3 people who currently hold the 3 positions? Okay, there's 2 ways you could think about this problem. Let's just do the first way. I think this first way might be a little bit more intuitive, and then I'll show you the other way. So this first way doesn't really involve permutation so much. I mean, it does, but it's maybe more intuitive for you. What's the probability of picking? So basically, when it says who currently hold the 3 positions, that means we want to pick the chair, and we want to pick the webmaster, and you might recognize the word "and" means times. So we want to pick chair and secretary and webmaster. WM means webmaster. What's the chance of randomly picking out of 17 people the one person who happens to currently be chair? Well, there's a 1 in 17 chance of that happening. Times, what's the chance of randomly picking the one person who's currently secretary? There's a 1 not in 17 chance now, because remember, we've just picked one of the 17 right here. So now how many people are left? There's only 16 people left. And then finally, what's the chance of picking the one person who currently is webmaster? There's a 1 in 15 chance. So that turns out to be 1 over, and then if you multiply those together, you would get 4,080. That's method 1. Here's method 2, using permutations. Remember, probability means what we want to happen, okay, over what could happen. So what we want to happen over what could happen. What do we want to happen? We want just a single outcome. We want the single outcome to be picking the 3 people who currently have it. So let's say Albert, Bernard, and Charles. Right? There's 17 people. We want that, and the order is going to matter here, because if we're picking Albert first, that means he gets to be chair. If we're picking Bernard second, that means he's secretary. If we flip those, that would mean that Bernard was chair and Albert was secretary. So the order does matter. So what do we want? We don't want just one thing to happen. We want Albert, Bernard, Charles in that order. What could happen? Well, we have 17 people, and we are picking 3 of them. That's what could happen. Why are we picking instead of choosing? We just said, because based on how they phrase this problem, we know that whoever gets picked first is going to be the chair, whoever gets picked second is secretary, and third is webmaster. So the order matters. If I pick in a different order, that means somebody's not going to be the chair. They're going to be, secretary instead, let's say. So what is another way of expanding 17 pick 3? Another way of saying that is 17 times 16 times 15, and you might recognize that from right up there. It's going to give you the exact same answer. So 2 different ways to solve that problem. Whichever one you find most intuitive, I think, is the better way for you to use.